In this video, I will discuss the topic Boyce-Codd normal form. It is also known as BCNF. So BCNF states that a relation R is in Boyce-Codd normal form if and only if every determinant is a candidate key. Now here determinant is a simple attribute or composite attribute on which some other attribute is fully functionally dependent. Now if A determines B, then A is the determinant. So let us see this example. Here we have a table in which there are 4 attributes: ID number, name, item number and quantity. Now as you can see, you cannot make ID number as candidate key. Why? Because there are duplicate values. Similarly, you cannot make name as the candidate key alone because it has duplicate values. So if we try to make FDs of the above relation, so we have to combine like ID number with item number to determine quantity. Only if we combine ID number and item number, then only quantity can be determined. Similarly, if we combine name and item number, then also we can determine quantity. So these are first two FDs of the above relation. ID number, item number can determine quantity, and name and item number can determine quantity. The other two FDs can be, if we know ID number, we can determine name because it is same. M101 is electronics USA everywhere. Similarly, if we know name, we can determine ID number. So these are the 4 functional dependencies of the above relation. And in these functional dependencies, what is determinant? The part which is on the left hand side of the arrow, means the attributes which are on left hand side. So in first FD, what is determinant? ID number and item number. So we will discuss this further. Now the relation has 2 overlapping candidate keys because there are 2 composite candidate keys. Here we have ID number and item number, and also name and item number. So there is a concept of overlapping candidate keys in the above relation. Now in the above relation, there is only one non-key attribute, that is quantity, and it is fully functionally dependent and non-transitively dependent on the primary key. So we can easily say that the above relation is in 2NF and 3NF. Okay. But manufacturer relation is not in BCNF. Why it is not in BCNF? Because the definition of BCNF states that every determinant is a candidate key. Now we have 4 determinants from the functional dependencies that we have derived. First determinant is ID number and item number. Second determinant is name and item number. Third determinant is ID number, and fourth determinant is name. So these are the 4 determinants, and out of these determinants, only first 2 are candidate keys. We can only make ID number, item number, candidate key, and name and item number, but separately ID number and name we cannot make them candidate keys. So BCNF does not hold true on this relation. So in order to make this relation in BCNF, we have to decompose the relation into 2 tables. First is ID name relation, in which we have kept ID number and name. We have removed the duplicate rows. There were 3 rows of M101, so we have removed the duplicacy from here. And similarly, the other table we have kept the attributes ID number, item number and quantity. We have removed all the duplicacy from the table. So now these normalized tables does not have insertion, deletion and updation anomalies. So these are now converted into BCNF. That's all for today. Thank you.